Hello, this is Lazarus at Telecom Tech, where telecom and networking technologies are simply explained. Today, we'll be simply explaining how to verify VPNv4 operation, as well as VPN label swapping and popping, all in the context of an MPLS network. In the previous two videos, we configured MPLS VPNv4 such that two remote customer sites are able to communicate with each other over the ISP infrastructure, completely isolated from any other customer networks. If you haven't already done so, check out those two videos first in order to fully understand what we're talking about in this video. Don't forget to subscribe, enable notifications, and click the thumbs up button to show your support and to enjoy every new video that's published. So here's our network. We have our customer networks on our CE routers, and we've configured the loopbacks and the physical interfaces of all the P and PE routers. We've also configured OSPF on the ISP underlay network, and we've enabled MPLS on all the P and PE routers as well. We also configured our VRFs in PE1 and PE2, along with our route distinguishers and our route targets. We created an IBGP peering between PE1 and PE2 to share VPNv4 routes. Finally, we created eBGP peerings between CE1 and PE1, as well as between CE2 and PE2, for the purpose of sharing those customer routes between those CE devices. Now, PE1 and PE2 have advertised those VPNv4 routes to each other, and they're using the VRFs, the RTs, and the RDs, as well as those eBGP peerings in order to have those routes advertised to the CE devices as well. Now let's start verifying the sharing of these routes by looking at the BGP table of CE1. Remember, CE1 knows nothing about MPLS, VRFs, RDs, RTs, and the like. It only sees an eBGP peering between itself and the PE1 router. Notice that you can see the local route has been advertised by BGP using the network command. You can also see that the 192.168.12.0/24 network that is advertised from CE2 has been learned by eBGP. And the next hop IP for this particular destination is the IP address of the PE1 router as expected. Similarly, you can see in CE2 the local network in the BGP table that has been injected into BGP using the network command, as well as the network that is on CE1, which is the 192.168.11.0/24. It too has been advertised using eBGP, and it has been learned by CE2. So we see that the networks have been advertised correctly to each CE router. Now that was a look at the control plane to see how BGP has exchanged those routes. Now let's take a look at the data plane. We'll see how data is actually transmitted over this MPLS infrastructure. In the data plane, we'll be able to take a look at the VPN labels and see how they're used by VPNv4 routes to direct traffic over an MPLS infrastructure. We'll use the traceroute command to take a look at this. If you do a traceroute on CE1 for the destination network of 192.168.12.1 using the local loopback as a source, we'll see something like this. In the first entry of the traceroute, we see a normal packet being sent from CE1 to PE1. As soon as PE1 receives it, it will push two labels onto it. The VPN label, which is the inner label, or the first label that's added. This VPN label is added because of the VRF that we configured that corresponds to this customer. In this particular case, the VPN label has a value of 20. A second label is added, which is called the transport label, or the outer label. This has a value of 18. Now this transport label is the same MPLS label that we have seen in all of our MPLS and LDP implementations so far. Now with this double set of labels, an inner label and an outer label, PE1 sends this packet to the P1 router. This P1 router will look at the outer label, or the transport label, and using the LDP mechanisms that we already talked about, it will take a look at the LFIB to see where this label should be sent. It will swap the label with the value of 19 and send it to the P2 router. It will actually ignore the inner or the VPN label completely. Next, the packet reaches P2. It looks up the label in the LFIB and sees the next hop is the PE2 router. Now, because P2 is the last P router in the path, it will perform penultimate hop popping on the transport label. So when the packet reaches PE2, it will reach it with only the VPN label intact. Once the PE2 router receives that packet, it will pop the VPN label and forward it to CE2, reaching its intended destination. Now, traceroute here gives us a hint of what's going on with the labels as the packet traverses the network. Let's take a look at those VPN labels in more detail. Here we have the data packet as it leaves PE1 for the P1 router. Looking at the MPLS header, we can see those two labels, the inner label, or the VPN label, and the outer label, or the transport label. Let's see what values are assigned to these labels based on the traceroute we saw earlier. We see that PE1 pushes the label 20, which is the VPN label, onto the packet, and also the transport label of 18, which is the label as it sees it in the LFIB for the P1 router, which is the next hop. That packet is then sent to the P1 router. That transport label is swapped by P1 and sent to P2 with the new transport label of 19, but the VPN label remains the same. P2 checks its LFIB and sees that the next hop is PE2. Thus, it realizes that it is the last P router in the path, so it performs penultimate hop popping on the transport label. Only the VPN label remains when the packet reaches PE2. Finally, PE2 will read the VPN label and will know that this packet belongs to the CE2 router, so it pops the label and forwards it appropriately. Now, one more thing that I would like to show you is how to examine the VPN labels in relation to the VPNv4 routes that BGP shares between the PE routers. Let's take a detailed look at the 192.168.12.0/24 route on PE1. First of all, I remind you that we had configured a VRF named green, and we had used values of 100:1 for both the RD and the RT. So in this output, we can see the VPNv4 route here with an RT of 100:1 prepended to the network. We can also see that this network has been learned in VRF green. The next hop address is 4.4.4.4, and the VPN label used for it is 20. The no label here indicates that there's no transport label associated with this VPNv4 route. This is the case at least within the BGP table. A couple more commands show additional information about these VPN labels. Once the packet is prepared to be sent, the transport label is added, and we can see this using the following command. Here you can see the next hop IP address of P1, the exit interface, and the transport label, as well as the VPN label, all in the same output. You can see the VPN label of 20 and the transport label as well. Now, just a small note about this part of the command. CEF stands for Cisco Express Forwarding. It's an advanced hardware-based routing technology used to optimize packet forwarding by creating a pre-computed lookup table, improving speed and efficiency in high-performance networks. When you use MPLS in such an environment, CEF records the transport and VPN labels, and that's why you can see them here. One last thing I'd like to show you. Take a look at the LFIB found within the P1 router. Here we see label 18, which is the transport label, the destination prefix or tunnel ID, which is the destination PE we want to get to, which is PE2, and the outgoing interface, as well as the next hop IP, which is P2. Notice that the P routers don't have any info about VPNv4 routes or VPN labels. They just route encapsulated traffic to the intended PE router. Take a look at the LFIB of the P2 router as well. Once again, you can see the transport label, but you can also see this P router will perform penultimate hop popping, since we see the pop label indicator here. We can see the exit interface and the next hop IP and the destination PE here too. But again, as a P router, we see nothing about VPNv4 routes or VPN labels. Finally, if we take a look at the LFIB of PE2, we see the destination of 192.168.12.0/24, and we see a V indicator here, which shows that this is a VPN route. The VPN label of 20 appears here since the transport label has already been popped. The next hop IP here and the exit interface are those that face the CE2 router, and we see no label in the outgoing label column, which means that PE2 will send a simple IP packet to CE2, which is what we want. Now that gives us an inside look at the VPNv4 routes and the VPN labels, and how label switching takes place when using VPNv4 over an MPLS infrastructure. I hope you found this video useful, and if you have, please click that thumbs up button. And if you have any questions or feedback, feel free to leave a comment, and please subscribe to get updates to newly published videos. I'm Lazarus at Telecom Tech. I hope this has been helpful for you, and I'd like to thank you for watching.